Hello everyone, welcome back to the channel. In this video lecture, we shall solve this problem longest consecutive subsequence. In this problem, we're given an array of integers containing n integers. We have to find the length of the longest subsequence such that elements in the subsequence are consecutive integers. The consecutive numbers can be in any order. The input will be an array of n integers, while in output we have to return one integer representing the length of longest consecutive subsequence. The constraints of the problems are: the length of the array goes up to 10 raised to the power 5, while the element in the array also goes up to 10 raised to the power 5. Let's better understand the problem statement using an example. So let's take this array. The array contains 7 integers and we want to find the longest consecutive subsequence. For this array, the longest consecutive subsequence would be 1, 3, 2, 4 because it contains integers starting from 1 and ending at 4, namely 1, 3, 4, 2. So it contains 1, 2, 3, 4. Hence, the answer for this input sample is 4 because there is no other subsequence which is greater than 4 and which contains consecutive integers. Let's see how to solve this problem. The very first approach, the naive approach to solve this problem is just sort the given array. After we sort the array, all the consecutive integers will be adjacent to each other. So here the consecutive integers are adjacent to each other. Therefore, what we can do, we can traverse over the array and we can keep track of the adjacent elements. If they are incrementing by 1, then we keep increasing the length of the subsequence, and if they are not consecutive, then we update our answer. So here what we can do is, we can see that if we start traversing from the first element, we can see 1, 2, 3, 4. So till I reach index 3, I have a consecutive subsequence and the length is 4. Then I see that the next integer 9 is not a consecutive integer. Hence I start another sequence from here. Then I see 9, 10 is a consecutive integer pair. Hence the length becomes 2 here. Then we move to next integer, which is 20, and we see there is no other integer after 20, hence the length of this subsequence becomes 1. The maximum length is 4, that is, this subsequence is the longest subsequence which contains consecutive integers. So that's the naive approach. This is the implementation for that approach. This is the function find longest consecutive subsequence, which takes in an array of integers, calculate the length of the array, then so it takes two variables. Answer will store the final answer, that is the length of the longest consecutive subsequence, while this count contains the length of the consecutive subsequences which I find in the array. Then I sort the array and I initialize another empty array to store the unique element. So I'm handling the case here that if the array contains duplicate elements, then I have to remove those duplicate elements. Then I iterate over this array and I check if the ith element is 1 greater than the I minus 1th element. If this is the case, then I am incrementing the count by 1. Otherwise, I am reinitializing my count and updating the answer variable with this. This is how we solve this problem in a naive way. What is the time complexity for this solution? So this sort function takes n log n time complexity, while we are iterating over the array once. That will take a linear time complexity, and here we are iterating over this array which stores unique elements. That is also going to take linear time complexity in the worst case, which will give me an overall time complexity of n log n. Therefore, this is my final time complexity. What is the space complexity? Since I'm using an extra array to store the unique elements, the space complexity would be linear. Let's see another approach to solve this problem. So approach 2 uses hashing technique to solve this problem. So what I'm doing, I'm using a set which will contain the unique elements of this array. So I push all the elements of the array into a set. Then I will iterate over this array and I'll check if the element which is just less than this element on which I am standing. So I'm standing on 1. I will check if 0 is present in the set or not. If it is present, then this 1 would become a part of the subsequence. Otherwise, if 0 is not present in the set, then I will start constructing a new subsequence from this integer. So that's the idea. Initially, I start from this element and I check 0 is not present in the set. Hence, I see that the length of my subsequence is 1 because I have 1 included in my current subsequence. Then I move to second element and I check if 9 minus 1, that is 8, is present in the set or not. We see 8 is not present in the set. Hence, we start another sequence from this element. So I have 9 included in my sequence now. Then I move to next element, that is 3, and check if 3 minus 1, that is 2, is present in the set or not. And the answer is yes, 2 is present here. Therefore, the sequence that I have at this point is 2, 3. That is 3 is a part of a sequence which contains 2 and 3 at least. It may contain 1, but all we know while standing here that 3 is a part of the sequence which contains 2 and 3, and 2 is present here. Then I move to 10 and I see if 10 minus 1, that is 9, is present here in the set, and the answer is yes, 9 is present here. Therefore, I see that 10 is a part of the sequence which contains 9 and 10. Then I move to 4 and see if 3 is present in the set or not. If it is present, yes, it is the case that 3 is present in the set. Then 4 is a part of the sequence which contains 3. Then I move to next element, that is 20, and 20 minus 1, that is 19. It is not present in the set. Hence 20 is not a part of any sequence which we already have. Therefore, we put 20 in another basket. Then we move to next element, that is 2, and check if 1 is present in the set or not. And the answer is yes, 1 is present. Hence 2 is a part of the sequence which contains 1. So 2 is a part of the sequence which contains 1. So 2 is a part of this sequence. So if 2 is a part of this sequence, then 3, 4 are also a part of this sequence. So 1, 2, 3, 4. So I copy this sequence into this sequence. So out of these three sequences, the longest sequence is this, and it has a length of 4. That is the answer. So let's see the implementation of this approach. So this is the implementation for the set approach or hashing approach. This is the set that we declare, and this answer will store the final answer, that is the length of the longest consecutive subsequence. N is the length of the array. We insert all the elements into the set, then we iterate over all the elements. We check if current element -1 is present in the set or not. If it is present, then we continue because this element on which we are standing is a part of already existing subsequence. Otherwise, we initialize j with the current element and we say, okay, j is the starting element, or the element that we are standing upon. It is the starting element of a new subsequence. So we find the length of that subsequence with this while loop, where we start from this element and we keep on checking the next consecutive integers if they are present in the set or not. And finally, we update our answer variable with j minus error I, where this is the initial element, the starting element of this new subsequence, and j is the final element of this new subsequence that we have found. Finally, we return answer from here. So let's see the time and space complexity for this solution. The time complexity for the hashing approach is linear because only one traversal over the array is required, or two traversals. One is to insert the elements into the array and another is to iterate over the array to check for the longest consecutive subsequence. So this is the case when we are assuming that the insert operation for the set and the search operation for the set takes constant time complexity. The space complexity for this approach is linear because we are using a set. Let's see another approach to solve this problem. Okay, so let's solve this problem using priority queue. So what a priority queue does, it stores the elements of the array into ascending order. So this is the priority queue. I have inserted all the elements of the array into this priority queue. So this approach is very similar to the sorting approach. In that case, we had to sort the array, while in this case, we get the sorted array in this priority queue and we start iterating over the priority queue. Initially previous variable which contains the previous element of the array, current length which contains the current running length of the longest consecutive subsequence, and answer which will contain the final length of the longest consecutive subsequence. So I will initialize previous with the first element of the priority queue and I will pop this element out of it and initialize current length with 1 and answer with 1. Then I will move to second element and I will check if the second element is 1 greater than the previous element, which is indeed the case here. Therefore I will increment the length of the current consecutive subsequence by 1. So it is 2 now. That is, I have a subsequence which contains 2 elements and the elements are consecutive. And I will update my final answer as well because the current answer is greater than the previous answer. And I will update the previous variable. Then I will update my previous variable with the current variable, that is with the current element, that is 2. And I will pop this element out of the priority queue. Then I move to the next element and check if the next element, that is 3, is 1 greater than the previous element. And the answer is yes. And in this way, I will keep updating my previous variable, checking if the current element is 1 greater than the previous element and hence incrementing the current length and the final length. And this is how I will extract my longest consecutive subsequence length in this answer variable. So this is the idea. The idea is similar to the sorting approach, but we are using priority queue, so we do not have to sort our array. Let's see the implementation for this approach. So this is the function which will give me the longest consecutive subsequence for this array. I'll calculate the length of this array, declare a priority queue, push all the elements into the priority queue, initialize previous with the first element of the priority queue, and this C is the current length, this max is the final length. So I will run until my priority queue is exhausted and I will check if the top element is not a consecutive element. That means it is not greater than previous by 1. Rather, the difference is greater than 1. In that case, I will start a new subsequence and the current length will become 1 while the top variable will become the previous variable, and I will pop this element out of the priority queue. Otherwise, if the top element of the priority queue is same as the previous element of the priority queue, then I will simply pop that element out of my priority queue. Otherwise, we have third case where the top element of the priority queue is 1 greater than the previous element. In that case, I will assign the top element to the previous variable and increment the length, the current length by 1 and pop the element out of the priority queue. Finally, I update my max variable, that is the longest consecutive subsequence length. Finally, I will return the max variable from here. So this will give me the length of the longest consecutive subsequence. The time complexity for this approach is also n log n because I'm inserting n elements into the priority queue, and the insert operation takes log n time, while the space complexity is linear because I'm inserting n elements into the priority queue. So let's see the implementation. I will be implementing the set approach because the set approach takes the linear time complexity assuming the insert and search operation are constant. So this is the function find longest consecutive subsequence, which takes in the array and gives me the length of the longest consecutive subsequence. So initially I will declare a set to store the elements of the array. Then I will insert the elements into this set. Then I will declare a variable answer which will store the length of the longest consecutive subsequence, and I will calculate the size of the input array. Then I will iterate over the elements of the array and check if the current element -1 is present in the set or not. If it is present, that means the current element, that is ith element, is a part of the already existing subsequence, and we continue from here. Otherwise, we want to find the length of the subsequence which is starting from this element. So that's why I'm iterating over the set starting from this element, incrementing j to check if the consecutive elements are inside the set or not. Then this j minus ith element will give me the length of the consecutive subsequence that I obtain, and I will update my answer variable from here. So this is the implementation in C++. Let's see the implementations in other languages. This is the implementation in Java, and this is the implementation in Python language. I've attached the code in the description, so make sure to check it out. And that's all for this video. If you like the video, then make sure to spread the word and give your feedback in the comments. I will see you in the next video.